Hello and welcome back. For the last part of the lesson on the chain rule, what I would like to do now is a bunch of examples. So we're going to look at a lot of examples using the chain rule, using a little trig, using a constant, using e to the x, doing a whole bunch of different things here. And let's see what happens. Alright, so in my first example, I want to find the derivative of f of x equals e to the cosine of x. So as we take a look at this, clearly we can see that this is going to be a chain rule here. We've got e, which is a constant, remember e is a number, to the power of the cosine of x. We've got the outside function and the inside function. Now what's the outside function and what's the inside function? The outside function is e to the u, and then the inside function is the cosine of x. So we need to think about, well, what's the derivative of e to the u, and then what's the derivative of the cosine of x? Rather than breaking it up, I think we can just do this one almost in our heads. The derivative is going to be, the derivative of e to the x is e to the x, so e to the cosine x, times the derivative of cosine x. The derivative of cosine is the negative sine. And then if I wanted to clean this up here, simplify it a little bit, I think I would put the negative sine x out front, e to the cosine x. There we go. There's my derivative. All right, another one very similar. How about if I have g of x equals e to the 3x squared? All right, so I'd like to pause for a minute, see what you can do with this one. Now think about the outside function, the inside function, the chain rule, and I've got e to the x. It's very similar to the one we just did. So go ahead and try this one, e to the power of 3x squared. Go ahead, I'll wait. All right, so let's see, what have we got here? So the derivative of e to the x, so g prime of x is going to be e to the x again, e to the u, the 3x squared, times the derivative of this. The derivative of this, power rule, is going to be 6x. And again, I think I would put the 6x, clean it up here a little bit, 6x e to the 3x squared. All right, let's take a look at one a little bit harder, a little bit more going on. What if I have y equals e to the negative 5x, and I'm sure we could do this part by ourselves, but I'm going to add times the cosine of 3x. So again, we've got chain here, but we've also got product rule going on. So we got, when we think about product rule, remember it's the first times the derivative of the second, plus the second times the derivative of the first, and we know when we take the derivative of this, we're going to have a chain in there. I could say that this is my first function and my second function and the derivative of this. Now, can we do this one without doing all of the u's and the v's? Let's see. So it's going to be the first. So the derivative y prime is going to be the first e to the negative 5x times the derivative of the second. Now the derivative of the cosine of 3x, I've got a little a chain in here as well, is going to be the sine of 3x times 3. Now the 3 is outside, it's not inside here, part of the argument. I'm going to move it all the way out here in a moment. So the first times the derivative of the second, derivative of cosine of 3x is sine of 3x times 3. Plus the second, I don't know if I have enough room to fit it here. Let's try. Cosine 3x times the derivative of the first. Now the derivative of the first of e to the u is going to be e to the negative 5x times the derivative of negative 5x, which would be negative 5. I put it in parentheses so we don't think that it's minus 5 here. There are two terms up here. This is one term, the second term. If we break it down and take a closer look, I've got the first times the derivative of the second, plus the second times the derivative of the first. We'll simplify and clean it up here a little bit. I'm going to pull the 3 out front. I'm going to have 3e to the negative 5x sine 3x plus, actually minus, right, the negative 5, if I bring that out there, minus 5 e to the negative 5x cosine 3x. And notice that both terms, I've got e to the negative 5x's in them. I can factor that out and have e to the negative 5x times 3 sine 3x minus 5 cosine 3x. And we're not going to break up these formulas or do anything with this. We're going to just leave it like that. That's our final answer right there. All right, what do you think? Let's take a look at some more examples. Here's another one. Y equals 3 to the negative 1 over x power. All right, so this one's pretty ugly here. This is definitely, I've got chain rule here. I've got my constant a to the u and du. Maybe we'll break this one down a little bit. My y can be written as some function to the u, which would be the outside function 3 to the u. My u, think about it as a g of x, is going to be the negative 1 over x. That's the power there. The derivative of my outside function, 3 to the u, is going to be 3 to the u times the natural log of 3. And remember, the natural log of 3 is just some number. The derivative of g to the x of negative 1 over x, think about this as negative x to the negative 1. Negative x to the negative 1, the negative 1 comes down, negative times a negative is going to be a positive, x to the negative 2, or 1 over x squared if you like. All right, so now let's put it all together. So my y prime is going to be the derivative of the outside, so 3 to the u, what is u? Negative 1 over x, times the natural log of 3, times the derivative, x to the negative 2. Okay? The derivative of the outside times the derivative of the inside. We can clean this up here a little bit. Let's see, what could I do to this? I'm going to leave this as 3 to the negative 1 over x. Natural log of 3, put it there. This gets a little confusing. All over x squared. This is a little bit awkward. Be careful. This is not the natural log of 3 times 3 to the 1 over x. This is the natural log of 3 times 3 to the power of negative 1 over x. Maybe I would want to put the natural log over here just to differentiate, to avoid this confusion. So kind of a tough one there. Another one, a difficult one. Let's see. I'd like to do a couple from the homework now. Some of the even numbered sets from the homework. First one I'd like to look at, this is number 38 in the homework. And remember, as you're working through these, if you have a hard time, the solution manual is over there on the filing cabinet, and you're welcome to use it if you come in before school to check some questions and your answers, or during class, or after school if you come in and you want to check it. You're welcome to go look at the solutions manual. So this one looks pretty crazy here. It's a trick though. As soon as you know the trick, it's a little bit easier. Y equals the sine of the sine of the sine of x. Yeah, that just kind of looks all sorts of things wrong. Now, be careful. This is not the sine cubed of x, because this isn't sine times sine times sine. If it was sine of x times the sine of x times the sine of x, then it would be sine cubed x. But this is the sine of the sine of the sine of x. All right, so let's break this one down and take a look here. My outside function is going to be the sine of u. There's my f of u. My u is going to be the sine of, let's say, v, and v is the sine of x. I've got a chain inside a chain inside of a chain. the derivative of sine we know is cosine. So here the outside function is going to be cosine u. The derivative of the first inside function is also cosine u, and the derivative of the inside function is cosine u. So if I put this all together, what would this look like? All right, so I'm going to have the derivative of the outside, the cosine of the inside. So this is going to be the sine of x times the derivative of the inside. What's the derivative of this? Well, this is the chain again. I'm going to have cosine of the inside bit, the sine of x, times the derivative of the inside. The derivative of the inside here, sine of x, is cosine x. And I don't think there's any simplifying we can do. There's not much we can do with this. Again, be careful. This is not cosine times sine times sine. We've got the cosine of the sine of x times the cosine of the sine of x times the cosine of x. Let's look at another one kind of similar to this, but not trig related. This is number 40 in the exercise set. And this is, my function is y is the square root of x plus the square root of x plus the square root of x. Now you saw the trick with the sine of the sine of the sine of x. Could you do this one? This is one that I would normally put on the board and give you a chance to try this one, see what you could do with it. It's a little harder than you might think, but it's got the same idea as the previous function. All right, so let's take a look at my my outside function, f of u, which would be the square root. And of course the derivative is going to be 1/2 the inside bit to the power u to the power of negative half. Now I've got an inside function here. My u is some sort of function, I'm going to call it g of v, because I've got an inside bit of the inside bit, which is the x plus that, x plus the square root of x plus root x. Oh, I'm running out of room over there. And actually, this I'm going to call v here. This is the v. If I call that v, let me make that correction, because I'm going to have another. This is going to be another chain rule here. So let's call that v, the square root of v. And what's the derivative of this? U prime. G prime of v would be 1 plus, and this would be v to the 1/2. So it would be 1/2 of v to the negative 1/2. And then my inside function is v, call it some h of x. So the inside of the inside is going to be the square root, this part right here is going to be is going to be x, and v prime of x is going to be 1. All right, so if we put it all together, what are we going to get here? So 1/2 of u to the negative 1/2. So here's y prime. 1/2 of u, which is this whole thing right here, x plus the square root of x plus root x to the negative 1/2 power times the derivative of the inside bit. Here's the derivative of the inside bit. It's going to be 1 plus 1/2 of inside bit v, which is going to be x plus root x to the negative 1/2 times the derivative of the inside bit there, which is going to be 1 plus 1/2 x to the negative 1/2. Oh, this isn't right, is it? This should be x plus root x. Oh, I made a mistake. I'm not going to start the video again. So the inside bit here was that, x plus root x. Its derivative would be 1 plus, and then that would be 1/2 x to the negative 1/2. That's the part that's right there. Sorry about that. Fix that mistake. Did you catch that? Did you see it? All right, so I've got the outside function 1/2 of the inside bit times the derivative of this, which would be 1 plus the derivative of this, which would be 1 plus 1 half x to the negative 1 half. And here I don't think I would do any cleaning up at all. I think I would just kind of completely leave it like this. All right, let's take a look at another example, another one from the exercise set. I like this one, number 43. I can't remember if I assigned it as a homework problem or not, but let's take a look at it anyway. Y equals 8 over the square root of 4 plus 3x. Now, do you notice that I'm going to think about this one as quotient rule. And within the quotient, I'm going to have a chain. So, do we remember what quotient rule is? The quotient rule is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Remember that little saying that we say to ourselves whenever we're doing quotient rule or product rule. So here's my derivative. I'm going to have the bottom 4 plus 3x to the 1 half, the square root, I'm just writing it with an exponential notation, times the derivative of the top. Derivative of 8 is 0. This whole term's going to disappear. Minus the derivative of, minus the top, 8, times the derivative of the bottom. Now here's where I've got my chain. I'm going to have 1 half of that to the negative 1 half. So 1 half of this, 4 plus 3x to the negative 1 half power, times the derivative of the inside. 4 plus 3x, the derivative of the inside is 3. There's not much cleaning up that I think we can do in here. I think the original problem asks you to evaluate it when x is equal to 4. So at this point, we would just plug 4 in here and then simplify it and evaluate it. But the next example I want to do a lot more on. Number 47, we actually have to find the equation of a tangent line. So this gives us an opportunity. So I want to take a look at number 47 now, because this gives us an opportunity to do everything that we're trying to do here. So number 47, it says find the equation of the tangent line of the curve y equals 2 over 1 plus e to the negative x at the point 0, 1. Now, the point 0, 1, when x is 0, y is 1. That should be on this curve. If I go ahead and confirm that, if we plug in 0 for x, e to the negative 0, e to the 0 is 1. 1 plus 1 is 2. 2 over 2 is 1. So that point is on the curve. That point is somewhere on the curve. So it's going to have a tangent line. And if I want to find the equation of the tangent line, so my final answer is going to be something in y equals mx plus b. Now I already know the point that it goes through. All I need is the slope now. And to find the slope, I'm going to have to take the derivative of this and then evaluate the derivative at x equals 0 to find the slope of the tangent line at 0. So of course the first part of this whole problem is the derivative. So let's take a look at this. Y prime is going to be, I've got product rule here again. So it's going to be the bottom, 1 plus e to the negative x times the derivative of the top, the derivative of 2 is 0. That whole term's going to disappear. Minus the top, 2, times the derivative of the bottom. Well, the derivative of 1 plus e to the negative x. The derivative of 1 is nothing. The derivative of e to the negative x is e to the negative x. And then there's a chain here, negative x. I have to take the derivative of negative x, which is negative 1. And of course, we don't forget that it's all over the bottom, 1 plus e to the negative x squared. So now here's our derivative. Now I'm not going to do any simplifying here. I'm going to evaluate it when x is 0. So I'm going to plug 0 in here. Now of course, this whole term is going to disappear. I don't care about that term anymore. So the derivative when x equals 0 is going to be negative 2 times e to the negative 0 times negative 1 all over 1 plus e to the negative 0 squared. Let's simplify this here a little bit. E to the negative 0 is 1. 1 times negative 2 times negative 1 is positive 2. over e to the 0 is 1. 1 plus 1 is 2, and 2 squared is 4. So there's my slope, 1/2. So I've got a point and a slope. The point of the tangency and the slope of the tangent line there. Now let's finish the problem by finding the equation of the tangent line. I'm going to use y minus y1 equals m times x minus x1. Use my point slope formula. Substituting in y minus, my y value is 1. The slope is 1/2. X minus my x value is 0. I get y minus 1 equals 1/2 of x. And then, of course, add 1 to both sides. My final answer is going to be y equals 1/2 x plus 1. There it is. So that's got a little bit of everything in it. It had a chain within a quotient, and we had to go all the way to actually finding the equation of the tangent line, which is really what it's all about. All right, that finishes chain rule. So working on the homework now. We should have the whole weekend to work on the homework, 3-day weekend. I know it's confusing, it's frustrating, it's tough. To be honest with you, the student solution manual kind of helps, but it's still very difficult to follow because it doesn't tell you, it gives you the answers and tells you the derivatives, but if you don't recognize them, you might not be sure what's going on where. But this is one of the more difficult things that we're going to do. Next week, towards the end of next week, we're going to talk about something called related rates, which is also pretty tough. But the next couple lessons aren't really terribly difficult. Nice, a little bit easier, but this is tough. This is one of the more difficult things I think we've done all semester. And gosh, I wish I was there. I could spend some more time and answer questions. Watch the videos at home, pause them, go back, rewind them, look at them again. Make sure you've got all the notes. Make sure you've got it all in your notebook. If you've got any questions, leave the questions in the comments section, and I will try to answer them whenever I can. Thanks, guys, and good luck. Have a nice weekend, and I will talk to you on Tuesday.